and today I'll be presenting the Tunguska asteroid event and the geology of the surrounding area. So, it was in June 30th, 1908, that a massive asteroid exploded over Siberia. It devastated the local area, rocked inhabitants, and killed wildlife. But interestingly, it wasn't discovered until 1927 when a Russian mineralogist was sent to perform a geological survey. So, the reason it took so long was partially because of how secluded the area was. So it wasn't near any major cities to attract the attention of the government, and also because of the time period. So in 1908, the world was just gearing up for World War One, and then during that, Russia would experience the Russian Revolution. But you'll see that there was still a lot of evidence of the blast even 20 years later. So to the right on this slide is a artist depiction of the asteroid entering the atmosphere, and to the left is a witness account. So the witness account comes from a peasant who was 40 miles south at Vanavara trading post, and he said that the sky split in two and fire appeared high and wide over the forest. The split in the sky grew larger and the entire northern side was covered with fire. He went on to say that his shirt felt as if it were on fire. The ground shook, and shortly afterwards, a great blast pushed him off his chair and threw him a few meters away. A hot Russian wind came, which left traces in the ground like pathways and damaged some crops. Later, we saw that many windows were shattered, and in the barn, a part of the iron lock snapped. So, where the asteroid exploded was over a region in Siberia known as taiga. It's a diverse region with rolling hills, wide valleys, and low mountain ranges. And featured in this picture is a dense forest similar to where the asteroid exploded. Beneath the topsoil is permafrost. Permafrost is a dense, frozen soil, and because it is so dense and frozen, it's halted geological investigations. But it is known that the rocks in the region is mostly basalt. Um, so here you can see some exposed permafrost. And basalt, as we know, is a fine-grained igneous rock, and it actually makes up 70% of the Earth's surface crust. And it is formed when magma or lava, when it's on the surface, cools very quickly. So this basalt was formed after ancient volcanic eruptions. And most of the active volcanoes in Russia today are much further to the east in a region known as the Kamchatka region. So here is the most active and largest volcano in Eurasia, one known as Kluchevskoy. And here you can see it erupting and some lava spilling out. So, sorry, just a little bit more about the Kamchatka region is that it does sit on a convergent plate boundary. It's on the far east coast of Russia. And so it's on a convergent plate boundary between the Pacific plate and the Okhotsk plate, which is actually a part of the North American plate. And that's what causes the volcanic activity and the earthquakes in the area. So it was during the previous ice age that Siberia was completely covered in ice. And it was the advancements and retreats by glaciers that formed the beautiful landscape like the valley in this picture. So here in this picture, you can see it depicts a U-shaped valley, as well as the jagged ridges above, which are called arates, and the cirques, which are the bowl-shaped hollows near these peaks. And then even the rocks scattered in the image in the bottom and around that lake there are evidence of moraines, which are like bulldozers that transport soil and rock as the glacier moves. So now that we've learned a little bit about this region in Siberia, we can better appreciate the destruction that was caused by this asteroid impact. So his name was Leonard Kulik. He was the Russian mineralogist that had discovered the effects of the asteroid impact. Again, 20 years later, but even when he came, he counted it to be 80 million trees that were flattened in an 830 square mile radius. And here you can see some of those trees. And then he estimated that maybe 100 reindeer could have died because of that explosion. So, sorry. Okay. So, how does the asteroid impact compare with any earthquakes in this region? So, the asteroid did trigger seismic readings, and it showed to have had a comparable Richter magnitude of 4.5 to 5, which is much larger than the average earthquake in this region. So the reason for that is that Siberia is actually, at least this region of Siberia, is interplate, meaning it's completely contained by the plate it sits on, which happens to be the Eurasian plate. So, as you can see from this image in the bottom left, the Eurasian plate is a large plate containing most of Russia, and it's moving relatively southward at a rate of 7 to 14 millimeters per year. Um, and it's one of the 8 major tectonic plates. It has boundaries to the south with other major plates like the African, Arabian, Indian, and Amur plates. And I'm sure regions like that experience much more severe earthquakes than um, ever experienced in this region. Okay. So, how does the asteroid impact compare with a volcanic crater? So, typically, asteroids and meteors they do leave craters. The main difference between a volcanic crater and an asteroid crater is that an asteroid is, of course, an external force, but a volcanic crater is more of an internal force. It's caused by gases and magma trying to escape to the surface. And then once it does, that volcano creates the top caves in and creates that crater. So, but because the Tunguska asteroid actually exploded about 3 to 6 miles above the ground, despite the devastation it caused, it did not create a crater. And there were no geological causes because it was purely chance that the asteroid um, were to enter Earth's atmosphere and strike where it did. However, because Russia is such a large landmass and probably the largest country, I think is the largest country on Earth, it's probably the most likely that it would hit Russia. So, the Tunguska asteroid is remembered every single year on June 30th, which just passed, as Asteroid Day. It was declared by the United Nations to remember how devastating an asteroid can be if it were to strike a populated area. So consider a city like New York City. It's 300 square miles, which is only half the area impacted by the Tunguska asteroid. And it's very fortunate that the world is mostly water and not likely that we'll ever experience such a devastating asteroid impact somewhere populated. And also that because of evidence of such impacts, NASA and other um, World Space agencies are constantly monitoring for asteroids and possible impacts. So these are the resources I used to produce this presentation, and I thank you for watching. Goodbye.